So periodic trends in properties. So yesterday we saw what is periodic what is periodic properties, what is periodicity. So you can see here um, anything which repeats itself after a regular interval is called periodic, and this behavior is called periodicity. So what are the periodic properties? Atomic radius, ionic radius, ionization energy, electronegativity, electron affinity. They show regular periodicity and hence they are called periodic properties. Next we started with atomic radius. So if it is metals, we call it as metallic radius, right? If it is non-metals, then it is covalent radii. So what is this metallic radius? Metallic radius, atomic radius in metal atoms is known as metallic radius. It is defined as half the distance between the nuclei of adjacent metal atoms. Can you see? These two adjacent atoms, half the distance. Okay. Next is in non-metallic elements. You can see the non-metallic elements. Their atomic radius is known as covalent radius. So it is defined as half the distance between the adjacent nuclei of two covalently bonded atoms of the same element in a molecule. So this example we saw, the hydrogen nuclei at the distance is 0.74 angstrom. So covalent radius is divided by 2, 0.37 angstrom. Now what happens across the period and the group. So this is what I told you yesterday. Um, down the group, across the period. Down the group, across the period. Okay. Here the nuclear charge increases. So what increases? Attraction increases. Size decreases. This is in period. This is in period. Now, in the group, okay, number of shells, that is orbits, number of shells increases, nuclear charge decreases, attraction decreases. When attraction is decreased, what happens to the size? Size increases. This is with respect to group. And this is with respect to atomic size or atomic radii. Radius will tell us the size of the atom. Now next we have to move on to ionic radii. So what is this ionic radii? Ionic radii is defined as the distance from the center of the nucleus of the ion up to the point where it exerts its influence on the electron cloud. Electron cloud. Yesterday I told you electron cloud. You must view the electron as a cloud. The punch mari you must view it not as electron a dot. Okay, but we will represent it as a dot. So, ionic radii is defined as the distance from the center of the nucleus of the ion up to the point where it exerts its influence on the electron cloud. Now, you can see, yesterday I told you how do you get a cation and an anion? When an atom, okay, gives its electron, it becomes positive. So we call this as cation. When an atom takes electron, it becomes A minus, anion. This is positive ion, this is negative ion. Cation, anion. Right? So, here yesterday I told you the size, okay, the ionic radii. When an atom, for example, see here, this is lithium atom. Okay, its radii is given in picometers. Picometers is 10 to the power of minus 12 meter. Okay, so here lithium 156 picometer, but when lithium has given one electron, see the size, its size has become 90 picometers. Okay, so the size of the cation, size of cation will decrease. Whereas if you see, this is fluorine, it has become F minus. Can you see the atomic size, radii? From 69 it has increased to 119. So anion size increases because it has taken one electron. It will be difficult for it to accommodate. In a bench only 3 of them can sit, but if fourth one comes and sits, they have to adjust and sit, but still it's able to take it. Okay, so the size of the anion increases, size of the cation decreases. Another example, sodium 186, whereas sodium ion 116. Chlorine is 91, whereas chloride Cl minus, it is 167 picometers. So here you know that ions are formed when an atom loses or gains electrons. When a neutral atom loses an electron, it forms positively charged ion called cation, whereas the gain of an electron by neutral atom forms a negative charge called negatively charged ion called anion. The size of the ion is important to determine their behavior in solutions and the structure of ionic solids. Size of the cation is always smaller. You can underline smaller than its corresponding neutral atom, but anion larger than its neutral atom. This is important. Note. As the positive charge increases, the size of the cation decreases. As the negative charge increases, the size of the anion increases. So they have explained wholly about the lithium and sodium, which I have explained already. Now, so as seen in atomic radius, ionic radii also decreases along the period from left to right and increases down the group. Can you understand? Can you understand? For girls, are you with me? Right. Whether it is atomic radii or it is ionic radii, the concept is same. The same concept. But if they ask atomic radii, and that what you must put, atom you must represent. Ionic radii potangana, you must put the word ion. Now, in the point here, you must add size of cation is smaller and size of anion is larger or bigger. Clear? Next.